In the previous video, we had clearly seen that this particular algorithm is not efficient enough to find the majority element. So in this particular session, we will see a efficient algorithm and we will write and execute over here. So what is that efficient algorithm? So the efficient algorithm is Boyer-Moore's majority voting algorithm. So what exactly does it do and how does it work? Let's see it step by step. So directly, rather than going to an array and finding the majority element, I would like to give a non-technical example and then we will convert that into our array. So if I take an example something like this, let's assume that there are 20 states in our country. I mean to say there are 20 states in India. I know my facts are wrong, but let's assume for this particular example. In these 20 states, let's assume that 10 states are in the northern part of the country and 10 states are there in the southern part of the country. Now, in this, let's assume an election has happened and I need to find which is that party which has won the election. So basically I need to find the party which is the majority. So what I would do is, let's assume in the southern part of the country, both the parties, let's assume there is UPA party and one more is NDA, and both these parties have won 5 and 5 equally. So think and then answer me that can I decide which is the majority on the basis of the southern part of the country? No. Now whichever is the majority in the northern part of the country, definitely that would be the majority throughout the country. Why? Because in the southern part of the country it is equally divided, 5 and 5. So in northern part, whichever is the majority will be the majority throughout the country. That's the basic idea behind this Boyer-Moore's voting algorithm. Now let's see how we can implement this particular algorithm into our problem. So if I just take an array over here, let's assume this is the array. Now I will try to implement the same thing over here. How would I do this? Very simple. What I will do is I will start from here. So I will consider this particular element, means I need to check step by step. So I will consider this to be the majority at starting. So as of now 5 is the majority. So let's assume 5 is one party. Next what I would do is I will consider two elements. So these are basically like two states and this is like the whole country. So among these two states, which is the majority? 5 is the majority. Next what I would do is I will consider 3 states. So if I consider 3 states, still which is the majority? 5 itself is the majority. I will consider 4 states. If I consider these 4 elements, which is the majority? There is no majority among these 4. Now over here there is no majority. Since there is no majority over here, what I would do is I will discard this part of the array. So basically what I am doing is I am discarding this part of the array. So this is what I have done. Now I can't say which is the majority by considering this part, but I can clearly say that whichever is the majority over here will be the majority throughout the array. So that's the basic idea behind this algorithm. So again what I would do is, since I am discarding this, I will consider this to be the majority. So this is nothing but 8. So 8 is considered to be the majority. I will go consider the next element or the next state. So if I consider these two, which is the majority? Still 8 is the majority. Next if I consider these 3, which is the majority? Still 8 is the majority. So since 8 is the majority among these 3 there is no more elements or no more states, I can clearly say 8 is the majority in this array. So if you clearly see this particular array, you can clearly see that 8 is the majority in this array. So this is the basic idea behind the algorithm. Now let's see how we can write code to this particular algorithm. So if you had clearly seen, what I did is I considered this element to be my majority at starting. So whichever is there at the starting index or AR of 0, that I will consider to be my majority. So I need one variable named majority. So and I will make AR of 0 to be my majority. Then what I would do is I will keep on checking, and if you observe, I went from this end to that end of the array only once. So I am definitely traversing this array and I am traversing once until from where to where? From the 0th index till the last index. So definitely I need one loop. And after that, what is that I am going to do is, every time I find the majority element, I will keep track of count. Now how would I keep track of count? I will show you step by step. So what I would do is, first thing that I need to do is, I need to pick this particular element to be the majority. So I will write that step by step. So let me write it step by step. So what I am doing is, I will take one variable named majority. So I will just write it as majority. Then I will say that's nothing but whatever is there in AR of 0. Now what happens is 5 is considered to be my majority. Next what I would do is, I need to keep track of count. So what I will do is, I will take the value of count to be 1. Next, after this, I clearly know that I need to traverse this complete array. Since I have to traverse this complete array, I know that I need to make use of one for loop. So I will write that as well. So I will say for. So the loop should go from 0th index till the last index. So I will say I will go from 0 to last. So that's nothing but the length of array. So I will say length of AR. Now what I do inside this is very important for this algorithm. So what I would do is, I need to find which is the majority. So I will use a simple mathematical thing. What I would do is, every time I find this majority element, I will increase the value of count. So if you see over here, what I will do is, when I see consider this element, is this equal to the majority element? Yes. When it is equal to the majority element, I will increase the value of count. Next, now the value of count would have become 2. Next what I will do is, I will go over here. I will check, is this element equal to the majority element? Yes, it is equal. In this case, again I will increase the value of count. Next again I will go over here. I will check whether this element is equal to the majority element. Still the majority element is nothing but 5. So it is not equal. So whenever it is not equal, what I will do is, I will decrease the value of count. So in this case, the value of count gets decreased and the value of count reduces to 2. Next again I will go over here. Now when I go over here, what happens is, again I will check, is this value, whichever is there in index 3, equal to the value of the majority element? Yes, sorry, it's no. So in this case what I will do is, I will reduce the value of count. Again, since I reduce the value of count, you can clearly see when I go from year to year, I would have increased in 2 places and reduced in 2 places. Since I increased twice, reduced twice, it doesn't make any sense. The value remains same. The value is still 1. Next, when I go over here and I check whether this element is equal to the majority, because majority is still 5. No, it is not equal. So what happens? The value of count becomes 0. As soon as the count becomes 0, I need to discard this array. So basically what I am doing is, whenever it is equal to the majority, I am increasing the value of count. Whenever it is not equal, I am reducing the value of count. But how to discard, I will show that. Before that, let me write how I need to increase and decrease the value. So what I will do is, basically I am finding whenever the element that but AR of I, is that equal to majority. So I need to write this within if, because I am checking the condition. So whenever this is the case, what I need to do is, I need to increase the value of count. So I will say count plus plus. Count plus plus. Now if it is not, then I need to reduce the value of count. So what I will do is, I will say else count minus minus. So till now we clearly know why we are increasing and why we are decreasing. Now I need to discard this part of the array and I need to make this as majority. When I need to make this as majority? Whenever the value of count reaches 0. So see, in this place the value of count reaches 0. So every time I will check, is the value of count 0 or not. So every time when I am iterating, I will check whether it's 0 or not. If I get it as 0, it means I need to discard the previous part of the array. It means the parties have, or the elements are equally divided. So what I will do is, I will check, is the value of count. So if the value of count is equal to 0. Now what happens is, basically over here, when I reach over here, the value of count becomes 0. Since the value of count becomes 0, don't you think that I need to make this element to be my majority? So how do I make this as my majority? So this element is nothing but AR of I. So what I will do is, I will say I need to change my majority. So I will say majority is equal to AR of I. Now since I am starting from here again, I need to reset the value of count back to 1. So what I will do is, I will say the value of count is equal to 1. So this is the algorithm and this is the Moore's voting algorithm. Now what we will do is, we will just trace it for this particular program and check whether it is working properly or not. Now let's trace this code for this particular input. So what I have done over here is, I have taken majority is equal to AR of 0. So AR of 0 is nothing but 5 in this case. So what I will do is, I will just write majority is equal to 5. Then after that I am told count is equal to 1. So I will make the value of count to be 1. Next, after this, what is that I need to do is, I need to traverse this array. So I am traversing from 0th index till the last index one by one. So I will come over here, I will check if AR of I is equal to majority. So AR of I is nothing but 5. Yes, it is equal to majority. Majority is also 5. Is 5 equal to 5? Yes. In this case, I need to increase the value of count. So now the value of count becomes 2. Next, what is that I need to do? I need to move the value of I. So I will increase the value of, before increasing the value of I, so if part has got executed, else part will not get executed. So this is, if block is completely a different if block. So definitely this will execute. It will check if the value of count is equal to 0. If you check over here, the value of count is 2. Condition fails. It will not execute this part. Now what happens? The loop executes. So now the value of I actually moves from here to here. The value of I has increased. Now I will check if the AR of I, nothing but 5, is 5 equal to majority element. Majority element is still 5. So is it equal to 5? Yes, it is equal to 5. Since it is equal to 5, I will need to increase the value of count. So now the value of count becomes, value of count becomes 3. Next, what happens is, again it won't execute the else part, it will execute the if block. If count is equal to 0. If you check, the value of count is 3 over here. So condition fails. So what happens is, again the loop executes, again it will check is AR of I. So before that, the value of I should actually move to 2. It's checking is the value of I, that's AR of I is nothing but 8, is it equal to the majority? Is it equal to the majority? No. In this case, the value of count should reduce. The value of count was 3. Now it will become 2. Now it will not execute. It will not execute if part. It executed else part. Now it has to execute this part of the block. Is count equal to 0? If you check, count value is 2. Condition fails. Since condition fails, it doesn't execute this part. Again goes increases the value of I. So now the value of I becomes 3. Again it comes inside the loop, checks is AR of I equal to majority. So AR of I is nothing but 8 in this case. So is 8 equal to 5? Condition is false. So what happens is, this block doesn't execute, so this part of the code executes, that's count minus minus. So now the value of count becomes 1. Now we have done till here. Next what happens, it will come and check over here, is the value of count equal to 0? If you check, the value of count is still 1. So it has increased twice, decreased twice, so it came back to 1. Next what happens, it will not execute this part, it will go and execute this part of the array. So it will check, is if AR of I is equal to majority. So the value of I actually increases. If AR of I is equal to majority, no, in this case the condition fails, since 8 is not equal to 5. So condition fails, it will come to this part and reduce the value of count. So this part of the code executes. Now the value of count actually becomes 0. Now it will come and check this condition, is the value of count equal to 0? Yes, the value of count is equal to 0. So it executes this to the block, this particular block. So majority is equal to AR of I. So now the value of the majority is getting changed. So this value will become AR of I. AR of I is nothing but 8. So you can clearly see that majority is changing. It becomes 8. And after that, the value of count is reinitialized to 1. So now the value of count becomes 1. So you can clearly see over here that this part of the array is discarded. So what you are doing is, you are reinitializing the majority value and reinitializing the count value. So basically this code has been repeated over here. Instead of saying AR of 0, you have told AR of 5. That's all you have done. But you are actually, you are discarding this part of the array. Now what happens? Again continue the operation. The value of I should increase. Now the value of I will increase over here. It will check, is the value of I equal to the majority? If you observe, yes, 8 is the value of AR of I, majority is 8, yes, 8 equal to 8. In this case the count increases. So the value of count becomes 2. So the value of count becomes 2. Next, after this, again what happens? It will come and check this part. Is count value equal to 0? No, the value of count is not equal to 0. So again it will go over here and check for the next element. So the value of I increases. It will check, is AR of I equal to majority? No, in this case AR of I is nothing but 1. So 1 is not equal to 8. Since 1 is not equal to 8, the value of count reduces. So the value of count reduces and it becomes 1. Next, what happens is, it will come and check this part. Is the value of count equal to 0? No, the count value is still 1. So after this, it will again go over here and you clearly know that you have reached the end of the array. So there is no other elements to be traversed. So you have actually completed this whole part of the array. Since you have completed this whole part of the array and you can clearly see the majority element as of now is 8. So whichever element is present inside this variable majority, once you have traversed the complete array, that element is considered to be the majority element throughout the array. And if you clearly see this array, you can clearly see that 8 is the majority, since 8 has occurred 4 times over here. So now what shall we do is, we will go and implement this particular code in the LeetCode and see how good our code is. Now let's implement that particular algorithm over here by writing the code. So at starting, what we need to do is, I had to create 2 variables. One is majority and the other one is count. So both are of integer type. So I will say int majority is equal to the first element. So the first element is AR of 0. So I will say AR of 0. So over here actually we have nums over here. So what I will do is, I will rename this to AR. So I will go to nums and I will rename it to AR. Fine. So so that I can use AR throughout. Next, I will come down to next line. Next over here I need to initialize the value of count as well. So I will initialize the value of count to be 1. So I will say int value of count is 1. Now we clearly know that we need to traverse the complete array from 0th index till the last index. So I will write the for loop. So I will say for the value of I should start from 0th index. So I will say int I is equal to 0 and I is less than till the last element. So I is less than AR dot length. So I will say AR dot length. Next, semicolon. Every time I need to increase the value of I by 1, so I will say I plus plus, I will come in. So every time what we used to do is, we used to check the element that we are checking for, is it equal to the majority element. If it is equal, we used to increase the value of count, or else we used to decrease the value of count. So I will implement that particular. So we are basically checking. So checking means I need to say if. So if AR of I is the element that I have, is that equal to the majority element? So I will say, is that equal to majority? If it is true, in that case I need to increase the value of count. So I will say count plus plus. So I told count plus plus, or else I need to say count minus minus. So I will say count minus minus. I will come to else part and I will say count minus. Now every time I need to check, do I need to discard the previous part of the array? In case if I have not found any majority, I need to discard that part of the array. So how do I check? Whenever the value of count reaches 0, that's when I need to discard the previous part of array. So what I will do is, after else part, I will again check one more if condition. So if is the value of count equal to 0? So I will say count equal to 0. So in this case, what I need to do is, I need to reinitialize the majority and reinitialize the value of count. So I need to pick a new majority, and which is that new majority? The element that I have in AR of I. So I will say majority is equal to AR of I. Next, after this, I need to reinitialize the value of count. So again I will say count is equal to 1, same thing over here. Yes. Now what happens is, we have clearly seen, after traversing this complete array, whichever element is present inside the majority element, that is the result, or that is the majority. So what I will do is, once I come out of the loop, whichever is there in the variable majority, I will return that particular element. So I will say return majority. Yes. So this is what I need to do. So what I will do is, I will just run the code first. So I am running the code. Yes, it has accepted. Let's see whether it's an efficient algorithm or whether it's better than the previous algorithm that we had seen. So previously, if you had seen, our code was actually among the last 5% of the submissions over here. Now let's see whether it has improvised or not. So what I will do is I will go and submit first. So it's checking for the test cases over here. So you can see in the previous case the time had exceeded. So run time is 1 millisecond, faster than 99.9%. So we are in top 0.1% of the submissions. So you can clearly see this is the best algorithm that we can write. So if you see the time complexity of this particular algorithm, you can clearly see that we are traversing only once in this particular array. So it's nothing but big O of n. So that is the time complexity of this. Now what I would like you to do is, in this particular problem, if I go to the description part, so can you take me to the description? So over here if I click, they had told one thing, the majority element is the element that appears more than n by 2 times. After this they have told, you may assume that the majority element always exists. So they basically mean to say, there is always a majority over here, there is always a majority in the input. But I would slightly like to change this question and I want you to go and write the code for it. So let's assume in a given array, they may be majority or they may not be majority. So what is the case they may not be majority? For example, over here there is 3 to 3. Instead of 3 to 3, if it was 3 to 1, there is no majority in this. So everyone is equally divided. So in that case, instead of printing any number, you need to print -1 because if there is no majority. Same case over here. Over here we have 4 2's and 3 1's. What I would like to do is 3 2's, 3 1's and 1 any other number. Let's assume it is 8. So we have 2 2, 1 1, 1 2 and then 8. In this case there is no majority again because majority element is an element which appears more than n by 2 times. So in this case also it should return -1. So I want you to go and try it out. I hope that you thought about this particular solution and you have written the code successfully. In case if you are not able to think about it, the approach is very simple. We clearly know that in our code, so if I go to the code part, if I just close over here, yeah, fine. So in this case, we clearly know that whichever element is present inside the variable majority after traversing this complete array, that is the majority element. Now I need to check whether it's really a majority element. So in this case they are clearly told there will be a majority element, so that would be the majority. But what the situation that I gave you, they may not be a majority element. In that case what you can do is, you need to traverse the array again and check whichever is there in majority, is that the count of that particular number, is it greater than n by 2? So basically what you need to do is, you need to traverse that particular array, you need to check whether the element present in majority is that equal to AR of I. If it is equal to AR of I, increase the value of count and keep the count of this particular element. And if the count of this particular element is greater than n by 2, that's a majority. I hope you will be able to implement this code.